Get rid of that. And we'll start off. I think this cartoon is very apt. Open system. Okay, that's a yes. So that. So hopefully you can all see my screen now. I'll get the chat on there. Right. And okay, if you can see my screen and you can see the
yep.
Cartoon. Right, good. Okay, should we start now? I think.
Go for it, yeah.
Yes. Okay. So, hello everyone. I'm Douglas Lowe. I'm a research software engineer at the University of Manchester, and I'm going to be teaching you today, this afternoon, about Git and version control. So I just want to make sure that everybody has created an account on GitHub. So could you please put a tick in the participants list if you have done that? And put a cross if you haven't, and then we'll try and sort that out for you. Okay, that's good. It looks like everybody has. Fantastic. Right, so version control. Why would we want to use version control? I think this cartoon from PhD Comics sums it up absolutely perfectly. We've all been there where we've created a document that we've gone, this is a final document, we think that this is what we're going to work with, and it happens for writing and for code, as well as for coding. And you finish it, you name your document, and then somebody changes it, and you get a revision. And if you don't have a version control system, the way that you track that is by changing the file name. And I've done this with Word documents myself, with collaborators, where you end up with a file name which is 20, 30 characters long with the different revisions from different people. So for code, you don't want to do this, because if you're working on multiple files, this is going to get messy, very, very messy, very quickly. So what we do is we use version control to do this control of that, this versioning for us. So the idea will be that we will make some changes, we can make some more changes, and we'll have a history of those changes that we can then refer back to as we are doing future work. So I will just stop sharing that, and I will share now the terminal. So I'm going to try not to switch too much between shared screens. So here we go. Hopefully I can do most of the rest of this in the terminal. So I'd like everybody to, I'm just going to clear all your ticks. If you could all open your terminal and go to your desktop. So open the terminal. So either Git Bash if you're on Windows, or the terminal, or the console if you're on Linux, or if you're on Mac OS, and then CD desktop. And you will have a desktop, you'll have a few bits and pieces on there. Can you tell me, is this screen, is that terminal readable? Is the text readable for everybody before I go any further? Or do you want me to make the text larger? If it's okay, a bit larger, okay, I shall let me just resize that. Okay, good. I'll just on this make that a bit larger as well. Okay, so hopefully, okay, that's interesting. I was hoping it would share both tabs, but it's only showing one tab. Never mind, I'll just have to work on this one. Right, okay, I am just going to then, you don't need to do this, I'm just bringing my notes to here, just so that I have everything in the same place. Okay, so what we're going to do to begin with is just get you set up with Git, make sure that you have the right settings on your local machine so that you can use the connection to GitHub when we need to. So what we will be looking at, we have git config, and this git config allows you to set the repository or global options for Git. So there are quite a lot of options here. We're just going to focus at the moment on your username and your email. So I would like you, if you could, to type this in. So git config global. So we're setting this globally, and we're going to set username. This should be a string, so if you could set that. Now replace my name with your name. So git config global username, and then we're going to use git config global user email. Now, this should be the email that you use to register for GitHub. So when you went through that registration process at GitHub, you will have put in an email address. Please use that email address here, because later on we're going to be connecting to GitHub and you need to have your global settings to be the same as they are on GitHub. I'm not going to enter that at the moment because I use a different email address for my work, for GitHub. There are options for keeping your email private. So I'll show you in a moment what I use, but for the moment, you should use your registered email address. Could you put a tick in the chat once you've all done that? Or, sorry, in the participants list. Okay, well, so almost everybody's finished. I'll just add a couple more commands now. This is for Windows only. So if you're working on Windows, you'll want to enter this. If you're not working on Windows, if you're working on Linux or Mac, you don't need to enter this command. But what we want, what we need to do on Windows is just make sure that the line endings are set correctly. So this is on Windows only. You need to set the line endings for any text files to have this particular control configuration, control string, because text files on Windows and on Linux have slightly different setups. Mac again is slightly different. So I'm not going to go into great details, but if you're on Windows, please enter that command. If you're on, you don't need to do this if you are on Mac, because it should be already be set. But if you're on Mac, what you would do is replace true with input. And also for Linux, you would replace true with input. But we're not going to go through that now. Now, for one other thing I would ask you to all do is to set your editor. So this will be, we're going to set it to nano. So what this does is it sets the command that Git will use when you are doing some editing of messages for committing changes. The -W means that Git will wait for you to finish editing. So if you are on Windows, then you can use a different editor. Now, is anybody on Windows who hasn't been able to use Nano?
So I couldn't use Nano on the yesterday.
Okay, I'm going to. Have you got Notepad++?
Yes.
Yes. Okay. I will in the chat. I'm going to post. I'm going to post that command, and if you could try copying and pasting that command into your editor, hopefully that should mean that I'm going to assume that you've got a 64-bit install. Hopefully that should mean that Notepad++ will be used when you are doing your text editing. Okay, so that should, so once you've got your options set up, you can do a git config list, and this will show you what your options have been set to. You won't have every single option in there that I have in there because I've been working with Git for a while. I've got a few extra bells and whistles. You will have a username and an email, and you should have a core editor. And those should hopefully, once those are set up, then we can start working with Git. So.
Sorry, can I just interrupt? Because like when I put in
Yes.
that git config list, it shows me like a
Yes.
very long kind of script, and it says alias dot and like different things.
Okay, that should be okay. Have you, within that, have you got a username and a user email?
I can't see it. Can I somehow like restart it and like do it again?
Which system are you on?
MacBook.
MacBook. Okay. Right. That's a good question. It's
I've just made an I've just made Nisa co-host. If
Oh,
she
I'm
hear
Nicole.
her.
Ah,
Oh, Nicole.
yeah,
Sorry,
so
I
if I
thought it
stop,
was.
Yeah. Sorry, let me just like join the meeting from like
Oh.
this laptop because I'm on a different laptop.
I made you a co-host.
Yes, 1 second.
right. So if you'd like to share your screen. So
Sorry, I thought it was Anissa who was speaking.
it's okay. I'm working on a Mac, but
Um,
I've made a lot of changes to my system, so
Can you make
it might be your setup's quite different.
Can you make the other Nicole as a co-host because I'm using like two.
Oh, okay, got you.
Thank you.
I just noticed that two of you.
Yeah, I had to join like the meeting from the other device.
You might get the same complaints from
Sorry, can you
OSX as I did.
co-host again? I had to change the settings on my laptop.
Shall I?
Yeah.
Shall I try to make you? Yeah, co-host again.
Yeah.
Is this working now?
Yeah.
Yeah, the Mac security settings have been beefed up.
Can you see that?
Ah, okay. Yes. So git. So you've got core exclude files, git ignore, right? This might be just a bit more verbose than mine.
So I think what I've done, I tried to put in the username first, and then I didn't add like the last quotation mark. And then like I think I like closed my terminal and like started it again, and then
Yes.
tried to put it again.
So you've got interesting. So could you scroll down a little bit?
Is there anything? Yeah, below the last command. So I think
yes,
there is
if
more.
You press space, and it should. There we go.
Yeah.
So we do have. It's just put it at the end.
So it was just longer than the all the commands and information in your GitHub config were longer than one screen. So it just continued by pressing the space. You just listed to the second page.
All right. Okay.
Yes.
So how do I
but
get?
that's good. So you press Q to exit that.
Okay.
Great. So yeah, that's a lot more detailed than my setup.
Yeah. Okay. So, but that's fine. Yeah.
Yeah. That's absolutely fine.
I'll stop.
Okay. Good. Okay. I shall share my screen again. So yeah, it's good to see some of the differences you can see in configuration files for Git, because every single computer seems to be a bit different. Right. Okay. I'll just get my setup working again. Right. So I will clear that. Unless if nobody has any more questions, then we'll move on to the next section and start looking at creating repositories. So I'm going to go through the scenario, which is in the course material later on. So it will be familiar when you come and have a look at this later on. There will be a lot more practical questions in the course material than I'm going to ask you today, because we're quite a bit limited on time. So I would recommend, after doing the course, do go back through that material again to make yourself familiar with it. There'll be more questions, more tests for you to try and get your head around some of the concepts for Git. So what we're going to do, I would like you to all CD to the desktop. So you should be in your desktop here. We're going to create a project repository for Wolfman, Dracula, and Mummy for their project of traveling to the moon. So we're going to call this project repository planets. So first off, as we learnt yesterday, we're going to make a directory, planets, and we're going to cd into that directory. Now, this directory is going to be our Git repository. So in order to set that up, we need to use the command git init. So this will initialize that repository. So we've initialized an empty repository here, and this directory here, the .git directory, is going to be where Git stores all its information about the repository. Now, when we look around, we don't see anything. That's because dot files are hidden by the bash, by the command line. So here we have .git, and that contains the configuration files that are used for Git. You never have to look inside of there. We're not going to go through that. But that's where all the magic happens. So currently, we have no commits. We're on for master or the main branch. Yours may be called. We have nothing commit there. So what we are going to do, so we can add extra files to this. Now, as we go through this, one thing I will stress is that that .git folder is the only .git folder that you need in that repository. So what you don't want to do is, if you create a new directory, you don't need to run git init inside of that directory, because those two sets of configuration files are going to clash. So we will get rid of that. So you can see inside of Moons, we have a .git, and we've got a .git here as well. But I'm going to remove that configuration file in Moons because we don't need that. So that's something to be careful with. Just make sure that you never open a Git repository inside of another Git repository. It can cause problems. So, has everybody created their planets repository? Can you put a tick in the participants list once you've done that? Okay, right, we shall continue on. So we're going to create some notes in this repository, which are going to be the project notes for this journey. So we're going to create a text file. So use Nano if you wish, or another text editor. But what we want to do is create this text file, put some text in there and save it. So I'm going to use Nano, and I'm going to type this in cold and dry, but everything is my favorite color. This is Dracula typing this, so we can expect red is going to be quite popular. And I'll try not to use VI commands. So Control O to save that, and we'll save that as mars.txt. And we'll exit that. So we have created our first file. So we've got mars.txt. So we are going to just show you we have that there. Now, git status. What we see here is we've got an untracked file, which is mars.txt. Now, one of the things I'll point out to you here is that we've got mars.txt and we've got the directory moons, but Git has only listed mars.txt. That's because Git pays attention to files. It doesn't directly pay attention to folders. So when you're creating a repository, you will be keeping track of the files. Now they can be inside of folders, and Git will then keep track of those, well, make sure that those folders are there, but it doesn't directly consider folders. So if you create an empty folder, you're not going to be able to directly add that to Git, to the records. So to add the Mars file to the records, we're going to use git add mars.txt. And then if you use git status again, so this status tells us about what is happening with the repository. We see that we're on branch master, we have no commits yet. The changes that are going to be committed are these. So the way that Git works is that you have untracked files or uncommitted changes in your local files, and then you have got dangers of home working. My girlfriend is on another work meeting. So we have the changes which you need committing. These are going to be files which are so we have files which are untracked, uncommitted changes, and then you have a staging area, which is those committed changes which are going to be ready to be committed. And then once commit has happened, that's on the actual Git repository itself, that's properly archived. So we are going to now take those changes which are to be committed. Has everybody got these added to their staging, to the staging position now? So do you all see this? When you type in git status, do you get the same message as I'm getting here? Please put a tick in the participant list. Okay, good. So what we are going to do now is we're going to commit this. Now there's two ways to commit. So whenever you make a commit for Git, you need to give a message as describing what you have done. So in this case, we're going to use git commit is the command we're using. -m means use this commit message. And this will go in the log file. And we're going to use the commit message start notes on Mars as a base. We press enter there. And this now tells us that we have got a commit with this random string here. And this is our commit message. And it's telling us that we have got one file changed, which has an insertion, and it's creating this Mars file with this mode. And that mode is kind of its permissions settings for this file system. So your string here might be slightly different than mine. This is a hash which is built out of the files which are in the repository. So it's a unique identifier for that commit. So now if we check our status, we see that we're on the master branch and we've got nothing to commit. Now that commit message that we used, we have this.
Sorry for interrupting. Sorry. The fact that I can't
okay.
see. No, I can't see because it's below the screen. Maybe it's my problem with my laptop.
No, maybe if I shrink that window a bit, does that make it more visible?
Oh, okay, perfect. Thank you.
Yes. Sorry, yes. I just had too much terminal open. So hopefully that's more readable for everybody. Put a cross in the participants list if you can't see that. Thank you for pointing that out. Okay, so if you type in git log, this will tell you what activity there has been in the repository. So here we have the git commit. This is the unique identifier for this commit. And it tells you who has made the commit, and you get this message here, which tells you about, that's the commit message we used, tells you what's going on. So we're going to add some more text to this file again. So nano mars.txt, and we're going to add in some notes about the moons. The 2 moons may be a problem. Problem for Wolfman. So we will save that. So that will be written to mars.txt. And so this is the code that we've added to that file. Now, what we will see now if we run git status is that we're on branch master, and we have changes which are not yet staged for committing. So that is, this file has been modified, mars.txt. So if we want to get rid of that change, we could use git restore, but we don't want to. What we want to do is to add these changes. So we're going to git add mars.txt again. And that will add the file, and it's now, we have that change to be committed. Is everybody up to that stage? Give me a tick to just let me know that I can move on. Actually, no. I am going to actually, before I do this, I missed a step. So I'll show you what happens if you don't want to commit a file that you have there. So I forgot the stage in the notes. So we're going to restore that file. So if you've added something to that staging and you don't actually want to commit it yet, you can use this git restore command. So these little commands, hints here, are quite handy for if you have made a mistake. So that now shows that we have that. It's modified, but it's not been staged. What I'm going to do now is show you. Now, this is quite a trivial example. We already know what the changes are here. But if you've been working on a large body of code, you've been editing, say, 10, 20 different files, you need to check what changes you've made. Git diff, and then the Mars or the file name will give you this information. Now, there's quite a lot to unpack here because these commands are, diff can be used for creating patch files for file. Git restore is not a git command. So that's interesting. Git, that's a good question.
It says, did you mean remote?
git checkout. So let me git commit git add Mars. So it might be that it's a slightly different version of git status. So git so git checkout. I don't think that git checkout would. Maybe it will actually. Git checkout. Maybe I have a newer version. Text. Let's. Can you try git checkout Mars.txt? I'm not sure that my setup will do similar. So if you, Beatrice or Martin, if you could try git checkout, probably might, no, that's not. Now this is one problem, is that I may be working on a slightly different version of Git to you. So it might not. Your setup might be slightly different. Let me just check. Okay, so the other you might wish to try.
I've put on the Etherpad at the very bottom what the git help commands show, like the checkout and all the other ones.
Okay.
I don't know if that helps.
It might now. The other
Line
option.
619.
Try. Yeah. The other option might be to try git reset. So I've used git reset there. There's multiple different commands in Git that you can use which almost do the same thing. So if you could try a git reset, does that work?
That says unstaged changes after reset.
Sorry, could you speak up slightly?
So it says that's done something. It says unstaged changes after reset Mars.txt.
That's absolutely what we want to see. Good. Okay, so as you can see, Git can sometimes be slightly confusing. I tend to refer to Stack Overflow sometimes with the more complex actions. I was hoping today we wouldn't have too much uncertainty, but working with different Git versions, this sometimes happens. But okay, so if you've made a mistake like this, you can use git reset, and that seems to work for everybody, or you can use a git restore if you're on a newer version of Git. So you can, if you're on a new, well, I assume newer version. I think I might be on a newer version. So if you have to, you can use reset, or you can use git restore. So once you're back to this situation where we have the changes not staged yet, if you run git diff Mars, then we get this information. So it tells us the indexing for which versions it is. You get this little bit of information about which files are being compared, and you get this information here about what's been added in the new version. So this is the next version there. So we're going to now add this file to our Git repository, and we're going to commit this, add concerns about so that I'll just make my window slightly wider. So we're adding concerns about the effects of Mars Moon on the Wolfman. So as long as you make that message informative for you later, it's fine to enter whatever you like. So we will now have there, we've got these changes. So now in the log, we have 2 commits. This string changes for each of them, and we have concerns about the Mars effect, and we have notes about starting notes about Mars as a base. Okay, so what we're going to do now, we will add one more change. So we'll do this quickly. So we're going to, nano Mars, and we'll add one more bit of code. So, but for mummy, we'll like for lack of humidity. So we will save this. So Control O to save and accept that. So rather Mars. So we've added this line of text, and we're going to add this, and we're going to commit I'm going to say discussing the mummy and climate. So if you could give me all a tick up, a tick once you've all done that. And once you can see in your log that you've got 3 commits there, and then we'll move on to the next section. Or move on to some questions, actually. Okay. So what we're going to do is, where was my get notes 048? Okay. So a quick survey for you. Which of the commands below would save the changes of myfile.txt to my local Git repository? So is it git commit, git init and git commit, git add, or this? So if you could enter that, are you? And in the chat, note down which you think, tell me which you think that would be. Okay, we're getting some strong votes for option 3 here. That's correct. So yes, so the first would only commit files which had already been staged. The second, we'll try and create a new repository, which we definitely don't want to do. And the third would be, again, just committing that. Would try and commit that file, but it hadn't been staged yet, so that wouldn't be sensible. So that's my first set of questions. My second set is a little task for you to try. So committing multiple files. So can you just go through these? I'll give you 5 minutes to work through that, because what I've done so far is just show you adding one file to a commit. Can you make a commit with 2 files? So add some text to Mars, noting a decision about Venus, create a new file called venus.txt and some initial thoughts about that, and then add both of those files to the staging area and commit those changes. And I'll give you 5 minutes to have a go at that, and then I'll go through that myself and show you how to do that. Okay, is everybody ready for me to show this example, or would you like a little bit more time? Okay, I think people are ready. Okay, so I've added some text to the Mars file with this, and I've added a new file, venus.txt. You can use nano if you like. I just wanted to do this a bit quicker. So if we look at the Git status, we have got changes not ready to be committed. We've modified Mars text, and we've got an untracked file. So we're going to add these. Now, what I'm going to do is add them both in the same command, but you could actually, what I'll do is add them separately. So you can see we've added Mars here. And if we add Venus, then they're both staged. Now, we can work on them at the same time. We don't have to do this separately. So we can, if we unstage both of them, we can add them together. So we can simply type in git add both files. So this will add them both. We can then just commit these. So we're going to commit with a helpful commit message. And now we will have 4 commits. Now this is our head commit. So this is the version of the history which we are seeing. This is where we are, this head, and this is the latest change. So writing plans to start based on Venus. So what we're going to do now is have a little bit of a look at how we explore the history of those changes to the files. So how can we identify old versions? How do we review the changes that we've made? How can we recover old versions? So if we wish to, so we have got Mars here. Now let's add some text to that. So we're just going to add a change to the bottom of the Mars file. So you can do this in nano if you wish, or you could use echo as I am here. If you're using echo, make sure to use 2 pointers here so that it's appended to the end of the file. So previously, we've used git diff. And this shows you the difference between what you have in the file and what's in the record that Git has. Now, we don't just have to look at the version that Git chooses for us, we can specify. So in this case, we're going to specify again the head, and this is the same version. So this is showing us that the head of that is the most recent version, and this is what we're looking at. Now we can look at previous versions. Now the way that we would do this is we can say, I want to look at the version before that head version. I want to look at the one previous to that. And we signify that using the tilde and a number. So in this case 1, it's for the version before. And this will show us then those changes. So if you look here, we've got this text, which is about starting based on Venus. And then we've got our second change here, this ill-considered change. Now, if you want to look further back in history, you can change this number. So we'll try head -3. So that is taking us practically back to the start of the code. So here we have our first commit for Mars, and then all the extra text that we've been adding. So we can look through this and look at the chain of commits that we have in our code. And you can go back as far as you have gone in your code. In other words, for some of my work, I've used version control to refer back to changes I made 5 years ago in code. So you can go, it keeps all the history. You can go very far back. Now, you don't just have to refer by absolute, and what's the phrase? My brain has gone blank. So what we've done there for trying to find commit is we've done it by reference. So we've said we're going from the last commit going backwards. So if you type git diff Mars, you don't, so is there no, the same for git diff. If you, so could you try git status, Simone, and tell me what information you get?
Okay, I try. I say on branch master, nothing to commit, working tree clean.
Okay, so so that would be git stash. So so you get that message, and if you use ls, do you have a Mars file and a Venus file?
Yes.
Yes. Okay. Interesting. So git diff Mars gives you that would be because there is no change yet. So you're comparing your current version of the file with what was previous. Sorry, you're comparing your current version with what you have at the moment. And because you haven't got any changes, okay. So if I Mars, so this is, if you cat Mars text, you should see this. Now, if I can remember my commands, there we go. So that was what we have. Git stash is a very helpful command if you've got lots of changes, but you don't want to mess with them, but you want to check something else. Git stash puts them in a safe drawer. Then git stash pop pulls the latest set of code out of that drawer again and puts it back in your working space. They're very useful. So what we have here, cat Mars and cat Mars text. So I now have that change. So if you make a change to mars.txt, you'll then, that git diff command will show you what that change is. If there hasn't been a change, so I now get this, but if there isn't a change, then it will just give you no message. It won't tell you you're okay, it's all up to date. It will just not give any message at all. Does that answer your question?
Yes, okay, thanks.
Yes, okay, great. So we have got this change here now. The other thing you can do, as well as doing it by reference from the last change, what you can do is you can take an absolute comparison. So these strings here we can use as a reference. So we can say git diff, I want to compare with this version what I have now. So I'm comparing my current version of Mars with the version which was in this commit. Now your commit string is probably going to be different from mine because these are based on what the contents are of that repository. So they will be different, very likely be different for everybody. So we do that, use that diff, and that shows you what was there in the history and how much change there has happened since then. Now you don't have to use the whole of the string. You only need to use enough characters to make it unique compared to any other commit. So usually I would use, say, 7 or 8 characters from that. In this case, we could probably just use 1. Maybe not 1. Okay, I take that back. So maybe it would like you to use 7. So as long as you have enough characters to make an unambiguous identifier for that string, you can shorten it. I was copying the string, so I just highlighted. Now, if you are working on Linux, I don't think you can copy out from the terminal. It's a bit awkward. This is why just using 7 or 8 characters is better, because you don't have to do the copy that I did there. So if I'm on Mac and I can copy off the terminal and paste back in again. If you can't do that on your system, just use the first 7 characters and that should be enough. So look at that string and go, okay, those are the characters I need. Type them in here and then you can get that difference. So if you could give me a tick when you've all managed to do that. Great, that's good. I'm glad to hear that, Manuel. So yes, so if everybody has got that sorted and is up to this stage as well, give me a tick and then I'll move on to the next section. I think so. Okay, great. So we have this change that we've made to Mars.txt. Now, if we don't want to use that, if we're wanting to do work on it at another time, we can use git stash to hide it away. That keeps a record though, and you could end up with a lot of waste in there. So if you don't want to save what's in that change, so if we don't want to keep this change, you can simply check that file out. So I'm going to check out Mars.txt, and that will update the file from our original index, from our controlled version. And now we have no status. So what there will be is it's just those original 4 lines. So if you've got some code or something that you've made changes, you don't want to keep those changes, git checkout will get rid of those changes for you, and it will revert you back to the version you have at that head. So you can do a git checkout head. This checks you out that version of a file from this top of your history. So here we are. It will check out this version here. Now, if we wanted to check out a previous version, we can use the identifying string again for that commit. So for example, I'm going to use this version again. Make sure that it recognizes it. And so we say git checkout version identifier file that we want to check out. And so that updates that file. And now if we run git diff mars, that now shows us that we have checked out that file, but it's been staged for committing. So if we think that's the right command, let me just check. I'm just going to, no. So if you are looking for help on a command, you can use git diff or git command help, or git help will show you all the information about that command or git itself. So that should be, sorry, git diff -- help. So I'm going to just, and if I'm wanting to okay. Right. Can't. What I'm just going to do is do a git revert mars, git restore, sorry. So yeah, so when we have checked out a version, a previous version, it will stage that change to be committed because it's expecting that what you're going to want to do is to replace the version that you have in the repository now with this new version. So what I've done is I've restored that so that it's not staged for commit. And I'll just show you that that is a change. So if I committed that, it's going to replace the file I have now with that old file. And so if I wish to get rid of that, I would git checkout mars again, and that will check out the version of that file from the head of the Git repository. So we are here now, and that is our base file. So if you want to check out a previous version, you can use git checkout and that string. Now, what we're going, as we're a little bit pushed for time, I'm going to skip the little quizzes on that. We will come back to those later on. I'll just show you how to add and ignore. So say that you have files that you're not interested in keeping. So you have data files which are being generated. So if we have, say, data files on Ganymede and Jupyter with a bit of a, so we have these two files here, and they're untracked. And whenever we do a git status, they're always going to be there. If we don't want to add those to the repository, they're just going to be in our information as when we're looking at the status of our repository. So what you can do is you can create a git ignore file. Now this, we can create, so I'm going to create here .git ignore. So we have a dot here because it's going to be a hidden file. It's going to be not visible as a standard in our terminal. And inside this, I'm going to specify that I want to ignore all files. So we use this wildcard here, and we're ignoring all files which end .dat. So we're going to ignore all data files. So we write that file, and we write it to .git ignore. So now have this file here. Now, if we run again git status, this is going to show us that we have got an untracked file, which is the .git ignore file, but it doesn't show us those ignored files. It just says, I've been told to ignore them. I'm going to leave them alone. You can, if you wish, see what's being ignored by adding this flag on the end. And that will show you both the files which you want tracking and also those ignored files. Now, to make sure that everybody else who uses this code can ignore the same files, we're going to add the .git ignore and git commit. So we're ignoring data files. That will now show us that we have this status where there's nothing to commit, working tree is clean. But if we add this ignored flag, then that shows us what we aren't interested in. Could you put, if that makes sense, if you followed that okay, put a tick in the participants list. Now you can do this with folders as well, and with other files, and you can have a range of messages. Now, the other thing, say we were interested in Ganymede, but we're not interested in Jupyter. We can add an exception. So that exclamation mark creates an exception. We're saying we're going to ignore all data files except this one. Now we could, if we were interested in data files which start with a G, we could use a wildcard here. And these this gitignore file is read from the top down. So each line overwrites the instruction or overrides the instruction in the previous line. So if we save that file, so that is going to be that we've got two commands here, and we don't want to ignore data files which begin with a G. If we then look at our git status, we have modified gitignore. Now I'm going to drop that, get rid of that change in a second, but we're now showing again that we have an untracked file, which is this ganymede.dat. So I want to ignore all data files anyway, so I'm just going to check out the git ignore file so that we get rid of that change. And that will now show us that we have nothing there to commit. So now I'm running slightly behind, so I'm not going to go through any examples for that at the moment. We'll come back, and if anybody has any questions, we'll come to those. But what I will do is we'll move on to working with GitHub so that I can show you how to create a repository on there. So hopefully we'll see what we can get done in 10 minutes, and then we'll have a break, and then we'll come back and continue on with GitHub. So I'm just going to stop this share and switch to my web browser. So bear with me a second. So right. So we're going to, if you could go to GitHub, please, and log in. So once in your browser, if you go to GitHub and if you log in to that so that we can create a repository, and I'll take you through the process of creating a repository on GitHub, and then we're going to push our changes, our local changes, up to that repository. So your GitHub front page probably won't be quite as busy as mine is here. But what we're going to do, if you could give me a tick just to show that you're there. And I'm going to click here. So up on the top right corner, there's going to be a button, and we're going to create a new repository. So if you find that plus button up there, and from that drop-down menu, select new repository. Now we're not going to work with a template for this. You're going to create it as yourself. Now, if you're in part of other groups, you will have a few different options for that, but we're going to stick with just creating it for in our name. And we're going to call it planets. And GitHub will check to make sure that you don't already have a repository called planets. You can put a description here. So we're going to say mission to Mars, or whatever you want to call it. And we're going to make it public. Now, we're not going to initialize this repository with anything at the moment because we're going to be uploading our own repository. So don't tick any of these boxes. Don't add a README or a gitignore, or choose a license for the moment. So once you have got all those options selected, can you then click on Create Repository, like this, and it should give us this page. So we are going to copy this path here. So we're going to stick with HTTPS, so secure HTTP, rather than use SSH. And we're going to copy that string. So we're going to click here. If you click on that button, that should copy that path for you. So can you all give me a tick to show that you've got that? Great. Okay, so I'm going to stop that share and I'm going to switch back to my command line. This is right. So now that we have got that path, what we're going to do is, so currently we have no remote. So git remote tells us what other repositories we are connected to that we have in our history, our records for this repository. So if we use git remote add, and we're going to call this repository origin. And this is good practice because a lot of the time you're going to use GitHub as your main storage for your repositories. And then you're going to copy them to a local machine to do some work and then push that back to those changes back to GitHub. So we're going to call it origin. And we're going to put into that the path to that web page. So that should now be added. So if I then check again, git remote verbose, that shows that we have this repository and it's set up for fetch and push. Do you all have this now? If you've, in your terminal, can you give me a tick to show that you've got that sorted? Okay, good. I think almost everyone. So what we'll do now is we're going to push this. So we're going to push. So we're going to push our, before I do that, so I'm just going to check. If you all do git branch -v, this will tell you what branches we have. So this is something we don't cover in this course, but you can have multiple versions of code within the same repository. Mine is called master. Now, other versions, there is going to be a move over to calling the main version of code main. So some of you might have a slightly different name. In this case, my branch is called master. So my command here is going to be git push origin because I'm pushing to this version. So I'm pushing to this remote repository, and I'm pushing the branch master. And I'm going to press that. Now, I have set up for because I work a lot with Git and GitHub, I've got set up that I have a key which gives me direct access to GitHub. So I don't have to put in my username, my password. Now, you will probably, when you enter that code, get asked for your password. That will be the password for GitHub. So when you do that, if you could enter your password, and then hopefully this should all work. So I'll just clear the ticks. If you could put a tick on there once you've got your branch pushed up to GitHub. And if you have any problems, then in chat, right, it doesn't let you put in a password, HTTP request exception. Now, Martin, are you, so if there's a key icon, that's probably going to be the request for the your password. So that would be where you type in your password, Nicole. Martin, request exception. If you type in git remote v, can you show this string? So can you, Martin, paste the string that you have your remote set to, so you can check to make sure?
It's on another computer, but
oh, it's on another.
I can put it on the Etherpad if that would help.
That would help, and I haven't opened that, but maybe Robert could then paste that to the chat for me. I should have that open, but then I just have too many windows. Thank you, Robert. Right.
I'll put it on line 791.
Line 791. Okay. So that should. So your remote information looks correct. Can you paste the error message?
Yeah, 795 is.
Now you. So we had an error occur, but it hasn't stopped it doing what it wants to do. So that
it hasn't
error occurred there. But if you now look at that repository, so what we'll do, I'm going to use your repository as the example. So if you now go back to GitHub and go to your location, I'm going to pull that over here. So what we'll see now, here is Martin's repository. So we have got here, we've got that code. So I have no idea what that error message was, but it is obviously not an important error message. Okay. Sometimes, I mean, yeah,
it sounded quite bad.
There's a lot of times that we get these error messages and they're not actually important. So here we have, so you've got your ignore file and we've got Mars and Venus. And the information that you'll have here, so once you've uploaded code, is you can click on that and it will show you, it will compare for you the changes. And you can see that there, if you have it, commit message, there should be a message there, I think. So over the break, because we will take a break now and we will reconvene at 3:30. I think I'll hang around for a little while just in case anybody has any questions, but just over the break, have a look at what you have on GitHub and just get familiar with some of, having a look around there, having a look at the different bits of information on that. And if you have any questions, hang around, ask a question. If you don't, take 25 minutes, get a coffee, bit of a breather. I've been kind of galloping through this a little bit, so you'll probably need a bit of time to uncompact your heads. I know I will, and then we'll reconvene at 3:30. Okay.
Doug, can you show the time on a slide, or shall I do that?
If you could show the time on this slide, I'll stop sharing. I haven't got one set up to hand.
That's okay. I'll do it.
Actually, are you going to be around at 3:30? Maybe I should do it.
You should probably, yes, because I might have to step out. That's true.
Yes. Okay.
Good point.
Right. I will just set
That's
up.
okay, and an empty document with the time should be okay.
Yeah, I'll just create. I'm going to do this very low tech. We'll just have okay. So yeah, this is going to be the most low tech option possible. So there we go. We will reconvene at 3:30 p.m. So when you arrive back, please put a tick so I know when most people are back and I can restart. Okay, I shall right, share my screen again, and we'll go back to looking at GitHub. So I'll just start off slowly. So we're going to be looking in the previous section. We went through how to set up a new repository, how to add changes to that, how to commit those and push those onto GitHub. Now we're going to look at how you collaborate with other people, with researchers, to both be making changes to your code. So I'll just show you on your repository, when you're wanting to collaborate with someone, you can add them to your repository. So if I'll show you this, we're not going to add anybody now, but I will show you where you can find this in GitHub. So if you have a look here, now this might, yes, here we go. So this settings button, if you click on this, then that brings you to these options. And these are set individually for each repository that you have on GitHub. So you can have different repositories for different projects. Each of these will have slightly different settings. So if we look at manage access, you will be asked for your password to continue. And I'm going to use that. I recommend getting yourself a password manager. I have a horrific memory, so I find it really useful. So this, if you go through there, log in so that it knows that you can make these changes, you can then see. Now, you can change between a public and a private repository, so you can change that visibility to make it public or private. If you wish to do these kind of changes, you have to, GitHub will ask you to confirm that this is definitely the repository you want to be doing this to. So it tries to make sure, because there are options in here like delete this repository. And if you want to do that, you need to type in repository name before GitHub will allow you to destroy everything because there is no coming back from that deletion. Once it's gone, it's gone. But what you can also do is you can add other users. And so right at the top here on Manage Access, you can add collaborators here. And you can invite a collaborator and for example, a colleague of mine, David, I could click on him and then you can click on add them to repository and they will be sent an invite to be a collaborator on that repository. So if you wish to add other people and you know who they are on GitHub, what their account name is, you can add them that way. You can also put in an email address if you want to send an email address to somebody to add them. But we aren't going to do that at the moment. What we're going to do is create an alternative repository on our local machine ourselves and act as if we're another collaborator making changes to the code. So I'm going to leave GitHub now and I'm going to go back to the terminal. So we shall, if I can find it, there we go. I'll add participants and the chat. Okay, so we are currently inside of our original repository directory. We want to change to the desktop. So cd /desktop. And you'll see here, we've got this planets directory. Now, what I'm going to do is I'm going to clone the repository, my repository. So I'm going to clone this. I need to, so if you on GitHub, on the front page of your repository on GitHub, there'll be a little green button labeled code. And if you click that, it gives you a drop-down menu, and you'll get the HTTPS path to your GitHub repository. Copy that. And then what we're going to do is paste that here. And we're going to give a name for this repository. So we're not going to, because if we clone that now, it's going to clone it into this directory that already exists, planets. So what we need to do is give it a new location that we wish to do that. And I'm going to do that because I want to record that I'm cloning a repository from somebody called Doug Lowe and that it's called planets. So I've just chosen to do it this way. Whatever works for you, you could say alternative planets or planets collaboration or something like that. But as long as you realize it's a different directory to the one you already have. And we press enter. And so that's going to pull the information down from GitHub. And we can now go into that directory. And if we look around, we've got the Mars file, the Venus file. Now, because we were ignoring those data files, we don't have those. And also, I had this directory which I'd created, but we don't track directories, so that hasn't been copied over either. So all that we have here is that Mars and Venus file and the git ignore. Now, we can have a look at the log with git log. Something that I forgot to show you earlier is that you can use git log one line so that you get a compressed log of your actions. So all you get is that first line for each of those log files. So log files, your commits messages can be longer than a single line. You could have multiple lines of information. There's best practice guides out on the internet describing how you should construct your commit messages in order that they are useful to people and mean that you can look back at your history later and work out what to do. So I'd recommend hunting those out. So here we have all our commits and that information. Now, what if we want to make some changes? So we're going to, here we want to talk about Pluto. So nano Pluto.text. And we're going to get very excited about Pluto. So we now have this file here. So we're going to add this. You can at each stage check git status to see what we're doing and git add, git commit. Now, if you just type in git commit without the message, what you'll get is you will get the nano interface because we've set nano. For those who have set Notepad++, what you'll get is you'll get Notepad opened with that text file in. Now you add the message above here. So we're going to say add notes about Pluto and then save that file. So we're going to do Control-O to write out. And it's going to ask, do we want to use this commit edit message? Yeah, we're going to use that and we're going to exit. And so that's now been added. Now, if you're using, say, Notepad, if we're using another editor, we put in this -w at the end so that the Git will wait for you to finish editing that note and pass it back before it carries on the next step. Now, if you were to leave that file empty, it would abort the commit. Sorry. So do I need to increase? Is that, sorry, Simone, is that more readable for you? So
yes.
My problem is that
yeah. So sorry, I missed two. So now I'm trying to. I'm a bit behind. But it's okay.
Okay, I will go through that again. Well, what I'll do is I'll add some more. So let's have. So I'm going to add Saturn. So nano Saturn, create this file. We're going to write that file. So we have got that file. We're going to add Saturn. So we now have this change which we're going to commit. And if we commit, we get this screen. Was that everything that you'd missed, Simone? So now, if I don't enter any text there, I'll show you what happens if I don't enter any text. We're going to write that file. Now, everything below this, below these, anything with a hash is ignored. So if I exit, then we get that command aborting the commit because Git wants a commit message each time. So you can't make a commit without having a commit message. So in this case, it's gone, you haven't written anything, I'm not committing. So I'm going to add a message. And we're going to commit that. So we have got these changes now. Now, if we have a look at that Git log and use one line in order to just look at the first line for each of these, we see we are here. So this is the version that we're at. So our head is equivalent there. This is the version that our remote repository is at. So the version on GitHub is a couple of versions behind us. So what we're going to do is we're going to push those up to GitHub. So we're going to push our changes up. So we're going to put git push, and we're going to push to our origin repository. So that's the GitHub one, and we're going to push to the master branch. And so now that has changed GitHub. So if you do that and have a look on GitHub, you will see that the version on GitHub is now this new version. I won't show you on my screen because it would mean jumping in and out of the terminal and I have to reset everything. But you can check for yourselves on GitHub, and if you could put a tick in the participants list once you've confirmed that that change has been made. Okay, so once you've confirmed that we've got those changes, then change to the original directory you were working in. So in this case, CD will do this by relative path. So go down a directory and then back up into the planets directory. So we will be in this location with these extra files. And if we have a look at the log, what you'll see is that we are level with the origin, we believe, because we haven't checked with the origin yet. And we're at that stage where we're ignoring data files. And okay, that's good. So I have no idea what that error is, Martin, but sometimes these errors they're just there and they happen.
It works.
Yeah, exactly. It works. As long as it's not stopped you doing the work, then it's not an important error message. It's a dangerous rule to live by, but it works. Okay, so what we're going to do now is we're going to pull. So we're going to pull those changes from the remote repository to our local repository. Or we might not know that there are changes. So we would just do this to see if anything has been changed. And here we go. And that pull Now, what did I say? Ah, right, yes. Okay, so what I haven't done is that I haven't said which remote branch we're tracking. So if I say that now, so we've pulled, what I've done is I've pulled for changes, but because I haven't specified a branch to track for a remote branch to track for our current local branch, all that Git has done is it's pulled the records of what's happened on the remote, but it hasn't applied them to our local copy because it is being careful. So it's going, you haven't told me that I definitely should just plonk all these changes onto this local version. So I'm not going to do that. I'm just going to pull the records and then we can apply those ourselves. So if you knew that you wanted to apply those locally, you would do git pull the remote and then the branch that you're on to apply them. We can also set the tracking information. So we can say git branch and set the upstream, so that remote branch to this. So I'll do that. Git pull origin master, and what's that's doing is that's pulling from GitHub, it's pulling the most recent changes and it's applying those to our files. So we've got these two changes. So fast forward, because we have no conflicts, it can apply those directly. And so we have got these changes here. Pluto text, Saturn text both have a change. So we've got two files changed, two insertions. And now we have these two files here. Now, what happens if we have conflicts, if we can't do that? So we're going to go back to, did that work for everybody? Before I move on, have you all managed to pull those changes down to the original branch, down to your original repository, sorry. Put a tick in the participants list if you have. Okay, good. Right, I will carry on. So if we go back to our new repository, so say we want to make a change to Pluto. And we're going to, we're a little bit concerned about the temperature. So we're going to say, but it is too cold. So we're going to save that and we're going to exit. So we're going to add this change. And we're going to say git commit message about Pluto. Okay. We're going to push that change up to the remote repository. So we've made change to that file. We're going to push it up. And there we have, so git log online. We have that warning about Pluto. So this is in our new repository. So that is our new code. Now, what happens if we make a change to the old code to our old repository and then try and pull that change back down? So we are going to, so we're in the original repository and we've got these changes here. So we're investigating 7. We're going to edit Pluto file. And we're going to be happy that it's cold. So we add this. So we have that file. We're going to add Pluto and commit that with the message so what happens if we then try and pull this down? We're now going to try and pull that. Has everybody made those 2 changes to the 2 repositories, pushed the change from the new repository up, and is ready to pull that change down to the old repository? Put a tick in the participants list once you're ready. And if you want me to go over any of those steps again, say so now. Okay. Great. So what we're going to do, our first test, we're going to do something that you should never do, is we're going to try and push our local changes up to GitHub before we pull the old changes, pull any changes down from GitHub. So we're just going to assume that our colleague hasn't made any changes to that repository which are important, and we're just going to try and push our changes up there. And what we're going to get is GitHub is going to tell us that we can't do that. And that's because there are changes on the remote version that we don't have locally. Now, you can force it up there. You can use a force command in order to just overwrite what is on that GitHub repository. Don't do that. Be very, very careful. There are a few specific situations in which you should do that. But sometimes it's very easy to lose everything because what you have on GitHub is not backed up anywhere. So it assumes that your local copies and your remote copies are the copy. If you overwrite what's up on GitHub, that's it, you've lost what's there. So be very careful before you force any changes in Git. So this warns us that we can't push our work up there because there is a change on there. So what we need to do is we need to pull those changes back down to our local repository, resolve those differences, and then we can push our local changes up. So what we're going to do, first off, we're going to, now we can do git fetch, which will just get information about the remote repository. So that's similar to just doing for git pull, but we're going to git pull origin master. Now this is going to try and apply those changes that have been made to our local version. Now, if it can't do that, it will tell you about these conflicts. So it's trying to auto-merge Pluto, but it can't because there's a conflict. So it tells us that we need to intervene manually and fix those those conflicts. So what you'll see if you run git status, you will see that there are unmerged paths and we have this message here, both modified. So this file has been modified by both remote repository and our local repository. That is the file that we need to edit in order to fix those changes. So we are going to, so if we have a look at that file, this is the information we see. So it shows us here, what Git has done is it has added this information here. So this section, the first section, is what we have locally. So the code that we had is this, or the text we have. This is the remote version. And what it will do is it will, every change in that file where there are conflicts, it will split and it will show you what you had and what the remote had. And then it's up to you to choose which you keep. So in this case, we're going to override the concerns of our colleague and say that we prefer cold weather. So we're not going to worry about it being too cold. So we're going to delete their change. Actually, no, we should consider their consent. But what we'll do is we'll keep that underneath. So what you could do if you didn't want to keep their change, you could get rid of it. Or we can edit it. So we could say, but it might be too cold. Now, it will look for those, for the head and for the other string at the bottom, which was the hash of the other change which had been made. And if it sees those in the file, it will still say, look, you have a conflict, you can't add this. So what we've done here is we've removed those, we've kept the text that we want. So we've edited the text where we feel that we should, and we're going to write that now to the file. So if we look now, we have unmerged paths, both modified, but if we git add Pluto, it will now apply that. So now what I should have done before I removed those is tried to add the file without removing them. And what you would have got is you would have got a warning, sorry, you haven't resolved the these conflicts, so Git would not add that file. So now that we've got those, we're going to commit these changes. We're going to make a note that we have taken our colleague's concern into consideration, and we're going to save that. So now if we look at that log, we see what's happened is that Git has taken the version that was on the origin and it's put that as our history. So if you look, our history is us working from here up. So it's taken that remote version as our history. It's applied your changes on top of that. And then we've resolved those problems and we've added a new version on top. So that now we can push to our remote, like this. And now if we go back to the other repository, we see it's our log. No. So we pull. So yeah, if you get that branch name wrong, then it doesn't pull anything. So we pull that down. Now in this case, because we've got a change to the Pluto file, it will show you that we've got a removal as well as additions. And you can look at that log file and see that we have those changes and that everything has been added. So does that make sense to everybody? Are there any questions about resolving conflicts, about merging changes in, that anybody would like to ask? If not, so there is a little bit more information and some exercises in the course material to talk. So there's some information about dealing with binary files as well as text files, which I'm not going to cover today because we are running out of time. But if you have a look at the course material afterwards and go through some of those examples, it will make clear some of these some alternative situations. So you'll get to see different situations in which these will need to be applied. So what we will do now is we're going to talk a little bit about open sites. So one of the benefits of using GitHub isn't just for your benefit of keeping track of what work you're doing. It means that when you then come to publish your research, that you'll be able to share with others the code and the objects that you use for producing those papers. So a lot of journals these days expect that you will share with the readers all of, well, not all of, but the important code and the important data that has been used to make your papers. So what I'm going to do now is I'm going to just share. So I'm going to show you a little bit on how that's done. So I'm going to have a look at this. So what I'll do is I'm going to just put some links into the Etherpad. So I'm going to do a little bit. So when doing these, it's always best to work with examples of work that you've done already. So if you have a look, one of the nice things about GitHub is that it has links to Zenodo. So if you're using the Zenodo, and I'll put these into the chat as well, for those who haven't got Ethernet open. If you have some data on GitHub, or you have a repository on GitHub, you can upload that to Zenodo so that it can be used in a paper. It can be referenced in a paper. So in this case, here, this is a Zenodo repository for some scripts that I used for running some model simulations. Now here, what you get is you get all the scripts, all the files which are in that repository, and you get, most importantly, a DOI that you can then refer to in your paper. And if you have a look at the paper, which I've put the link in the Scratch space, and have a look just about before the acknowledgement section, there is a section about code sharing. And we give information there about what data we have used for that paper and where you can get that data. Now, in order to create this Zenodo repository, when you create that Zenodo record, you can link it to a GitHub repository. And inside of that repository, you want to do a couple of things now. One thing you want to do is specify the license for that code. So when you're sharing code, it's very important to specify a license. Now, we hadn't yet done this. Now, this website here, Choose a License, is very useful to explain the different open source licenses which are available for you when you wish to share your code. Now, having a license there, because GitHub is an open site, and a lot of the time you won't have your repository private, it will be open for anybody to access. You don't know what use people might want to make of your code. They might find it very useful. They might want to use it in their own code. If you have a license file in there, that helps them work out if they can use your code and what they can do with that. So if, for example, you want to make sure that it's very simple, that it's permissive, and you say, I'm happy for anybody to take my code, do whatever pretty much whatever they like with it, you could say use the MIT license. So this one here, and it's very simple, saying, okay, it's software provided as is, so there's no liability on yourself, and permission is granted for anybody to take a copy, do with it as they wish. I have, for this code here, my license is the MIT license, as I'm just happy to share that code. And what you would do then is place a copyright there inside of that file. So you can create this license file in your repository. And when you're creating repositories on GitHub, this is one of the things it will ask you is, do you want to add a license? So you can add a license there and specify how you want your code to be used. Now, there's a lot of considerations on choosing a license. On OS X, the latest versions of OS X have moved to the ZSH shell rather than the bash shell. And it's believed that the reason that Apple did this was because the change in license for bash meant that they would have had to share some of the changes that they'd made to bash. So I think they moved over to ZSH, not because it was better than bash, but because it has a more permissive license and it allowed them to do what they wanted with that software. So this is, when you're using software, one of the first things to look for is what licenses do they have? What can I do with that? So one of the things in here, I had shared some government data for the paper that I was working on. That has been shared under the Open Government license. And I had to read through that before I shared this data to make sure that I could share this information. And I'm allowed to do that. So because that had that license there, I could decide that I could share this in the paper when we were doing this study. So that's the first thing, is you should set a license when you create a repository. At any time you can add that. The other thing that you should do is make sure that you have a README file in that code. So on GitHub, if you have a README file, that will be displayed when anybody looks at your repository, and it will give them a bit of a guide on how to use that code. And so these here, this is a quick guide, just very basic. Don't need too much, but just a bit of information about what you're doing with that. So in this case, I just had a couple of steps in there advising on how to use those scripts. So, and the other thing I would say is when you are creating from Zenodo, it will link to a version. So you can create a tag, a version of that code. So once you're happy with code and you know that it's going to be used for a paper, you create a tag and then you release it. So this is a big benefit of using sites like GitHub. I think that maybe GitLab as well is accessible from Zenodo, is that you can then link to your code and to data as well. There is, in the notes, there's a link to Git-based repository for large data sets as well. And so you can link to that data, to that code, when you're writing your papers, and it makes the whole process a lot more transparent and easy to follow so that your research can be more reproducible. So I don't know if anybody has any questions on that. I think, Alex, that I'm just about at the end of the session. I don't know if there's any wrapping up that you want to do.
Yes, thanks very much to Doug. Can I just also invite some questions here at this point about GitHub or anything else we've covered over the past 2 days?
Yes, I realized this was being a little bit of a gallop through rushed introduction to Git.
This is a very intensive course, yes.
If anything wasn't clear about Git, do ask now. Yeah.
How do people feel about Git? Yeah, how do people feel about Git? Do they feel that this is something potentially interesting and useful? That could be interesting or useful for them.
Yes, Martin asks the origin statement. So origin is the name that we gave to the remote repository. So you can have multiple remote repositories. I might have an example I can show you if I stop sharing.
So it is convention, Martin, that the remote repository that you are working with or interacting with is called origin, in the same way as the default branch is called master, or now it's renamed to main in Git, but you can GitHub, but you can also rename. So this is just convention.
So is main the local one?
No, main is the remote one, and local one. Once you start working, you have copies of the remote branch and the local branch, and then they are supposed to be in the sync, and then they have the same name.
Yes. So
it used to be called master. The main one used to be called master, but now GitHub's renamed that to main for some reason. I don't know whether this is to address.
Well, yeah, I mean, in computer science, computer work, we used to refer to master and slave for different processes.
Yes, and perhaps that kind of language is not
very inclusive,
appropriate or inclusive. So I think they are working to change that. So now the default branch is main.
Yeah, here we go. So this is an example. What I have done here. So origin is my local version of this repository. And I've labeled remote, which is because WRF is its weather research and forecast model, which is being developed in America, very large user base. So I've pulled their version, I've made my local changes, and I store that in my local version on GitHub. But what I do is that their remote version, or their version I call remote. So I have linked it to 2 different repositories on GitHub. And so origin is a convention, but then you can add other versions on. So if I was to try and push something to them, I would say git push remote master, which I'm not going to do because that would cause trouble. But you can, if you have other remote repositories you link to, you can specify to them by changing that. So not using origin, you'd say remote or upstream or something like that.
Okay. So this is a very good example. This is a very good example. It might not make sense just yet for you. So typically how it works is if you come across a project that you want to work or contribute to, you do what we call a fork. So you fork that original repository, and then you have a fork in your, for example, GitHub. So once you download that, well, your fork onto your local machine, then you have your local copy, and the copy on your GitHub account is called origin. So it is a remote copy of what you have locally. However, there is the copy from where you forked. Okay, so you can actually contribute your changes back upstream, as Doug said, to that to that project, and that is actually remote in this case. And you can have several of these. Yeah. I suppose that's probably not a very likely scenario, but a scenario where you have a fork which you interact by doing something locally and then pushing to your origin on GitHub, and then pushing those changes upstream back to that remote repository is quite common.
It is. So I'll just put those links in the chat. If you have a look at our local link, you'll see then that it should be labeled that it's been cloned from their main link. So yes.
So this is for collaboration when you have, for example, a large number of collaborators that you don't want to add necessarily to your GitHub repository. But you will probably most often have the case where you work on a GitHub repository where you actually have direct access, so you don't have to work in this manner where you push your changes upstream via pull requests. That's what we call a pull request, when you request your changes to be incorporated in that remote. So it's much easier when you actually either work with your own repository or you work with your colleague's repository where you have direct access, and then you can, well, still you should probably use pull requests to push your changes into that repository, but you can also do that directly. You can push your changes directly without going via the pull request route. But this is kind of a more advanced Git usage. It's still good to know, and you will probably, as you learn more, you will come across this terminology.
Yes, it's good practice to get into, but yeah, not for today. So
GitHub interface is very, very nice, and it has improved a lot over the years. And you can do many, many different things directly from the GitHub interface, making it easier. So if you find Git working from command line too hard, you can probably still do quite a lot just by using GitHub interface. However, if you're coding, you just simply won't be able to do that via GitHub. So if you want to version control your code, you will have to develop that code locally and be able to push those changes onto GitHub so that you can back them up in a way and share with a larger group of collaborators. So for things like developing websites or maybe keeping some documentation in Markdown in GitHub, it is actually okay to just use the GitHub interface, and it's actually very user friendly, and it's a very gentle introduction to Git, which is behind it. But for coding, you simply won't be able to code within GitHub. So you will have to be able to interact with it via Git and command line, unless you have a nice graphical, we call these IDEs, integrated development environments that have a graphical support for Git. So for example, RStudio has this, and then you can actually just point and click and do all these Git operations through the graphical user interface.
Yes,
Still, it's good to know what's happening under. Yeah, go on.
There is an introduction to RStudio and Git, I think, in the material, which I haven't gone into, but the last lesson I think it introduces doing that.
It's still good to know what's happening underneath, because if you, even with the graphical interface, you can very often get into a situation when you've done something that you didn't intend. And then it's good to know, to understand the error messages and to understand a bit of Git to know what's the problem. And then Google is your friend. Stack Overflow, I think Doug mentioned, if you find one of the top hits when you search for something will be on Stack Overflow, and then you just head there and you'll most likely find your answer there.
Yeah. Always Stack Overflow usually has the best answer for a problem. So yes.
So what other questions do people have? Okay, if people don't have any questions, I have two things to ask of you now. I'll share my screen. So below line 884, we just want to ask you in a similar way that you've been doing over the past 2 days to give us a quick feedback on Git module. So once you've done that, I'm going to paste a link to a post-workshop questionnaire, which is linked to from the workshop website as well. Now, this is the feedback that goes back to the carpentries who have provided this material to us. This is going back to the community. And it's also going to help us improve and fine-tune these lessons and the way that they are delivered. So this is a constant process. We are often asking you for feedback because we want to know what works better for people, or what works best for people. And these workshops are normally delivered in an in-person setting, and we had to, since the lockdown, we had to do a massive online pivot to be able to continue to deliver these. However, they don't work exactly the same as an in-person setting, but we hope that they were still very useful for you and that we've managed to deliver as much of the content as possible and carry the spirit of the carpentries to this workshop as well. So just leave us some feedback in Etherpad, fill in the post-workshop survey, and you're free to go. Thanks very much, Nicole. Thanks, Martin. It's I think you all are members of the same community, NBIC. And from my personal experience, sticking with the community, finding people who work on the same things, on the same problems, or using the same tools is very useful. So never suffer alone. Find some collaborators. There are loads of different communities around. There are different Python communities. There are PyData, PyLadies, RLadies. They also have local chapters or regional chapters. There are loads of data communities. There are also loads of communities around open and reproducible research. Try and find your tribe. There is the carpentries as well, which you're most welcome to join as well. We also welcome new instructors. If people are interested in becoming instructors and passing on their knowledge, we love people who come from domains, different domains, because they know the domain problems and they can relate to people and they can better teach people from their own domains than perhaps us who come from a different background. Or if you want to be a helper at one of these workshops, we'd also welcome helpers. So thanks very much, everyone, and good luck with using all these new